So okay, now I welcome to you to the C++ programming lecture 5. Okay, and today we will be going to continue where we have left in the previous lecture. This is Yashivasa, and let us start today's lecture. So today we are going to talk about what is standard template library. Okay, in the previous class I was just talking about the polymorphism. Okay, and this is and that has two types. That is, one is a virtual function, and second one is a template, right? So now we are going to talk about standard template library. Okay, so see here, over here, as a container, it is divided into various parts, out of which we are talking majorly going to talk about this two, that is sequence and associative, and we will be getting a brief idea of all the others. Okay, so see over here, sequence, what it has, vector. Okay, vector, what how it is used, it is written over here that array is contiguous memory. Okay, and it is nothing but it just what it does, it just replaces the realloc. Okay, now you are wondering that what is realloc. That is alloc is a short form of allocation, and how we are going, how we use it, that we will be looking into in next lecture. Okay, and then this is list, doubly linked list. Okay, in doubly linked list it is also used as a container in the form of sequence. Okay, what we use here, it is basically you might read about the doubly linked list in your DSA. Okay, DSA is a very major topic in the whole CSC department, and there basically what it is used for, it is helpful in fast insertion and deletion of the data into any list. Therefore, that is where we are using this linked list. Okay, so okay, I'm going to be explaining you here in detail, otherwise I won't be able to cover all the topics. So this is what the doubly linked list is. Okay, then DQ. DQ is basically a result of function of DQ. Q. Okay. So suppose this is a queue. So we are having some data inside it. So if we begin to remove that thing from the from the behind it, or you can say from the previous thing, then it will be called as DQ. And where it is used, it is just using the double-ended queue. Okay, where we can see it once again, where we can see it, we can see it in a double-ended queue, right? Then where else is stack? Stack in a simple form, I can tell you, suppose you have kept books one over another, that is just a stack. Okay, so that you can pick up the last input will be the first output. Okay, that it was a stack in queue. Here just now I told you that the first input is the first output. Okay, first thing you kept over here, then second thing when you will be keeping, this first thing will shift to here, then next thing when you will be giving input, this thing will be shifting to here, and then ultimately the first thing will be the first output. And similar in the sense priority queue. Priority queue is just specifically like this queue, and for detail we have to see it into next lecture. So then associative, it has three types: map, set, and multi-map. Okay, so what is map? Dictionary, balance tree of key of comma value, and pairs. Okay, like array with non-integer indices. Okay, then what is the next? Next is the set, map with values. Okay, so only key important. That is how this this container of a standard temporary and standard template library is going to be used as associative in the form of set. And what is the use? That is overwritten over here. Then at the end there are some more, that is multi-map and multi-set. Okay, what it actually allows for, this is written over here, that allow duplicate keys. Okay, what it does, you need not to have always the original keys. You can use the duplicate keys also over here. Okay, so this is a multi-map and this is a multi-set. Nothing but just the extended form of this map, and just an extended and more convenient way of this multi-set, but it should be used only when it is required. And others, it is just written over here that string, basic string, not necessarily contiguous. Okay, these things not necessarily to be contiguous. That is what string and basic string. Then val array means value array, that is the vector of numeric computation. Okay, that is what, that is nothing but just a vector. I told you in detail in the previous lectures. No, I guess I have told you in the C programming in detail that what is a vector for numeric computation. Okay, for numeric computation we are going to use this val array and then bit set. It is nothing but just a set of n bits. Okay, it is very clear. The last one was a very easy. Now, yes, here if we continue, we have again algorithms. Uh, I would recommend you to better read all these names, that this is non-modifying. Okay, these are modifying algorithm and these are some other algorithms. Okay, find, search, mismatch, count for each. These cannot be modified. Okay, that's why it's written over here. And copy, transform, apply, replace, remove. These are actually meant for modifying. Okay, copy you can modify. Okay, replace is another thing that which is used for modifying. Then remove also. These are the standard libraries that are basically used for modification. Okay, and these are not used for modification. Okay, then what is written over here, that others are unique, reverse, okay, random, shuffle, sort, merge. Sort, you have a completely different topic. Okay, quick sort, selection sort, then merge, then partition. Okay, we will be dividing, sometimes we will be dividing the array into some parts. Okay, partition. Set union, set intersection. Union, you know what union contains, all the values. Intersection just carries the common values of the two given sets. Okay, then difference, what are the difference in between, like if you remove, you can say unius intersection is the difference. Okay, next is minimum, maximum, minimum element, maximum element. Okay, then next, permutation and previous permutation. These are the things which comes under the algorithm section of the standard template library. Now I think I should move on. Now coming on to the virtual function of derived class is called even if you have only a pointer to the base class. Okay, function of derived class is called even. This function is called even if you have only a pointer of the base class. Means it is necessary to have a pointer to the base class. Okay, then only it will be called as a even. And here its algorithm is written over here in terms of file.h and then in terms of file.c. Here we are making a class of shape and writing algorithm inside it, and then this class circle is having a public access of this class shape. And here in this same case, what we are doing, we are just making two classes, that is void function 1, void function 2. And here this circle, my circle and function and my circle is storing the address of it. And in this case, we are just, what we are doing, we are using a shape pointer to s. Okay, then s is nothing but is telling to draw. Okay, now that depends upon the question that what does this draw specifically mean over here. But for now we can say that it is calling the circle draw. Okay, circle draw. This is a command which I might be written in the other parts of the code. So now, what is the penalty of a virtual function? Okay, so see over here, for space different penalties, and is for time different penalties. So in case of space, one variable per classes is a virtual function. Okay, one variable per class with a virtual functions, that is what a penalty in space, and one pointer per instance. Okay, this is what the penalty for you for the virtual function. Okay, that one v table per class with virtual functions. In case of virtual function, one penalty for per v table, right? And for the case of instance, one penalty for the case of one pointer. Per one pointer we have to pay, you have to pay a penalty. Okay, for instance. Then for time, one extra dereference if type not known at compiler time, and no penalty if type known at compiler time. Okay, so that is what it is training. One extra dereference if type not known at the compiler time. Okay, if you don't know the type at the compiler time, then one extra dereference, and or in this case, the other case, no penalty if you know the compiler time. Okay, if you know the compiler time, no any penalty is there. Okay, so I hope it is clear. And then finally, pure virtual function. So pure virtual function is nothing but function intentionally undefined. Okay, function intentionally undefined. Some penalties are regular functions. Okay, some penalties as regular function. Then what we are doing over here, we are talking about the abstract class. What is abstract class? I have told you in detail. Then class, what is the name of this class? Shape, and what is written over here? Virtual void drop. Okay, then contains at least one pure virtual function. Okay, what it does, it contains at least one pure virtual function and cannot instantiate. It cannot instantiate, must derive from the base class and override pure virtual function. Okay, it must be derived from the base class and it should override the pure virtual function. Okay, and provide an interface. Okay, this is just a simple thing written over here. Then advice, what is advice given to the developer? That virtual function should always be pure virtual. Okay, when you are using virtual function, try that it should always be pure virtual. Okay, and here are the two examples given that how this pure virtual function should be. And one more advice is given over here, that make virtual functions private. Okay, try to make these virtual functions private. Okay, this separates override implementation details from the public interface. Okay, and it why it is said that, because it just simply separates the override implementation details from the public interface. From public interface, it will simply override implementation details. Okay, so I hope this is clear to you that what is the STL, these templates, and what are the virtual functions. So I will see you in the next lecture. Till then, thank you.